This video accompanies Learning IoT with Python and Raspberry Pi. In this video, you will learn how to use the dictionary type. The dictionary is a mapping type used to store key-value pairs. An empty dictionary can be created using a set of empty curly braces or using the dictionary constructor with nothing passed as the argument. A dictionary can be created by enclosing a series of comma-separated key-value pairs with curly braces. Only immutable types can serve as keys. For instance, ints and strings can serve as keys. Both immutable and mutable types can be the associated value. The naming convention is to use the underscore dict suffix in the name of a dictionary, but this convention is often not followed. The value of an item can be changed by assigning the new value to the item. In order to add an item to the dictionary, the same syntax can be used. An item can be accessed by following the dictionary with square brackets that enclose the key of the item. To delete an item from the dictionary associated with key 1, say, use the delete function with the item to be deleted passed as the argument. Calling the pop method on a dictionary will cause the item associated with the key passed as the argument to be removed and returned. We'll enter a dictionary interactively and name it parts_dict. The key and value of the first item are both string types. The key of the second item is a string, while its value is an int type. The key and value of the third item are both int types. The key and value of the fourth item are a tuple and a float, respectively. And finally, the key and value of the fifth item are a string and a list. We'll access each item in the dictionary one by one. In order to access the item associated with the tuple gas sensor, 1, you need to include the entire tuple as the key. We'll change a value associated with the key breadboard to the string 1000 sockets. And we'll display the parts dictionary. And here you can see that the value associated with breadboard has been changed to 1000 sockets. We'll add a new item with the key value pair, the string light dependent resistor, or LDR, and the integer 20,000. We'll next delete the item with the key LDR from the dictionary. However, the delete function has passed an item that is no longer part of the dictionary, then a key error will be raised. The value associated with a particular key can be changed to a different type. Before, a list of ints was associated with capacitor, and now a string is associated with capacitor. You can view the methods available to dictionary types by following the name of the dictionary with a period and pressing the Tab key. A for loop can be used to iterate over the items in a dictionary. We'll next write a script that stores the mass densities of certain metals in a dictionary, with the name of the metal as a key and the density of the metal as the value. The user should be able to do the following multiple times: display each metal and its mass density, enter a new metal and mass density, remove a metal from the dictionary, and find the mass of a metal cube of a size entered by the user. The script should take into account that a user might attempt to remove a metal or calculate the mass of a metal that is not in the dictionary. Also, the script should take into account that the user might fail to enter a floating point number for the mass density or for the size of the cube. Feedback should be provided to the user about whether or not a certain operation was successful. The mass of a metal cube can be calculated if the density is known and if the size of the cube is known. Mass is equal to density times side of the cube cubed. In order to make this program more manageable, we'll place each task into its own function. Display underscore metals, add underscore metal, remove underscore metal, and mass. We'll also write a function named display underscore menu, which prints out a menu of the 4 choices, and a main function named main underscore metal, from which the other functions are called. We'll outline the main underscore metal function. We'll name the dictionary that contains the mass density of each metal densities. Note that in this example, we won't follow the convention of naming dictionaries with the underscore dict suffix. The mass density dictionary will initially contain gold, silver, copper, and aluminum. We'll place this assignment statement at the beginning of the main underscore metal function. Because a user should be able to add a metal, remove a metal, display the metals, and calculate the mass of a metal cube as many times as he or she wants, we'll use a while statement. We'll use a sentinel control while loop that keeps executing as long as the user enters 1, 2, 3, or 4, which will correspond to the 4 menu choices. The user will be prompted to enter a choice. If the user wants to add or remove a metal or calculate the mass of a metal of a certain size, then the user will be prompted to enter the name of the metal. If the user wants to add a metal, then the user will also be prompted to enter the mass density. If the user wants to calculate the mass of a metal cube, then the user will also be prompted to enter the size of the cube. These input function calls will be placed in the main underscore metal function. We'll enter the functions one by one, beginning with the display underscore menu function, which prints out to the shell the menu of 4 choices. Display metals, add a metal and its mass density, remove a metal, and find the mass. This function has no parameters, and it returns nothing meaningful. The display underscore metals function prints out every metal and its mass density. Hence, this function expects the mass density dictionary as the argument. We can use a for loop to iterate over the items in the dictionary. After the for statement, we use an extra print function call to add a blank line, making the output easier to read. This function also returns nothing meaningful. The add underscore metal function is defined to have parameters densities, metal, and den underscore string, which correspond to the dictionary of mass densities, the name of the metal to be added, and the mass density of the new metal as a string. We place the assignment statement, which adds the new metal to the dictionary, inside of a try except statement that handles the value error that would be raised if the user did not enter a number. The message invalid value entered is returned if a value error is raised. Otherwise, the message metal added is returned. The remove underscore metal function is defined to have parameters densities and metal, which correspond to the dictionary of mass densities and the name of the metal. We'll pass the item to the delete function. If the metal is not in the dictionary, then a key error will be raised. If a key error is raised, then the message metal not in dictionary is returned. Otherwise, the message metal removed is returned. The dictionary is a mutable type, and the densities parameter in both the add underscore metal function and the remove underscore metal function reference the same dictionary object as defined in the main underscore metal function. This is why the densities dictionary does not need to be returned. The mass function is defined to have parameters densities, metal, and side underscore string, which correspond to the dictionary of mass densities, the name of the metal, and the size of the metal cube as a string. We place a statement that assigns side underscore string converted to a float to side, and the return statement that returns the mass of the metal cube in a try except statement that handles a value error that would be raised if the user failed to enter a number for the cube side. A key error would be raised if the user failed to enter a metal that's in the dictionary. In this return statement, we enclose the concatenation of strings in parentheses for implicit line joining. Also, the calculation of mass formatted to 2 decimal places is also part of this statement. The first line in the main underscore metal function is the densities dictionary assignment statement. Then the display underscore menu function is called to print out the menu of 4 choices. The user is prompted to enter a choice. We index the string returned by the input function in case the user enters more than 1 character. The while loop will execute as long as the user enters a response that begins with 1, 2, 3, or 4. We'll use an if-else statement to determine if the user entered 1 or something else. If the user entered 1, then the display underscore metals function is called. Otherwise, the user is prompted to enter a metal. We call the input function from the else clause because only the functions that add a metal, remove a metal, and calculate the mass of the metal need the name of a metal. The nested if, elif, else statement is used to determine which of the other 3 functions to call. If the user entered 2, then the user is prompted to enter the mass density. The add underscore metal function is called. If the user entered 3, then the remove underscore metal function is called. Otherwise, the user is prompted to enter the size of the cube, and the mass function is called. We put the add underscore metal, remove underscore metal, and mass function calls as arguments to print functions because those 3 functions return strings, which we wish to print out to provide feedback to the user. At the bottom of the while statement, we'll place an display underscore menu function call and also prompt the user to input another choice. And we'll save the script and the function definitions. And we'll run the code. Entering 1 causes the metals in the dictionary to be returned gold, silver, copper, and aluminum. Next, we'll add titanium to the dictionary and its mass density. And you can see that it has been added to the dictionary. Now, because copper is already in the dictionary, its value will be modified from 8.96 to 8.94. And we'll add lead. Because a typo was made, a value error was raised when the script attempted to convert the user response to a float type. Hence, lead was not added to the dictionary. Now we'll remove a metal. We'll enter lead. Because lead was not in the dictionary, a key error was raised, which was handled by the try except statement in the remove_metal function. And we'll try to remove a metal again, this time aluminum. Because aluminum was in the dictionary, the delete function did not raise a key error, and the aluminum item was removed. Now we'll calculate the mass of a cube of gold that is 2.5 centimeters on each side. If we attempt to calculate the mass of a cube of zinc that is 2.5 centimeters on each side, a key error will be raised because zinc is not in the dictionary. And now we'll try titanium, but a value error is raised because of the typo when we enter the size of the titanium cube. And this time there's no typo, and the mass of the titanium cube is calculated. Go to www.learningiot.net for links to where you can buy Learning IoT with Python and Raspberry Pi.